Good day, everyone. Welcome to my new blog entitled Trigonometric Identities. Let's start with a discussion. All right, we have six trigonometric functions such as sine, cosine, tangent, cosecant, secant, and cotangent. For each value, we have for sine, it is equal to y over r or the opposite over the hypotenuse. For cosine, it is equal to x over r or adjacent over hypotenuse. And for tangent, it is equal to y over x or the opposite over the adjacent. While for the counterpart of sine, we have the cosecant, and it is equal to the reciprocal or the inverse of the value of the sine. So it is equal to r over y or hypotenuse over opposite. And for the counterpart of cosine, which is the secant, it is equal to r over x or the hypotenuse over the adjacent. And for the cotangent, it is equal to x over y or the adjacent over the opposite. Let's move on. Now, let's have the first trigonometric identities, which is the reciprocal identities. I'll show you the first three. Alright? So as I've said a while ago, the counterpart of sine is the cosecant, and the counterpart of cosine is the secant, and the counterpart of tangent is the cotangent. Now let's start with the reciprocal identities. Therefore, we have the first one. The reciprocal identity of cosecant is equal to what? 1 over sine theta. Then question, what would be the reciprocal identity of sine? So obviously, the answer is 1 over cosecant. Alright? So the second reciprocal identity is the secant theta. So it is equal to 1 over cosine. And obviously, the value of the reciprocal identity of cosine is equal to 1 over secant. Let's move on for the last one. So we have the cotangent theta is equal to 1 over tangent theta. Let's proceed. So let's go back with the famous coordinate, the x and y coordinate. Since we are talking about trigonometric identities, let's have the trigonometric coordinates. So it is what? Cosine and the sine. Why? Because cosine is equal to the x and sine is equal to the y. Now let's proceed with the quotient identities. So before that, let's view the first, the six trigonometric identities that I've shown you on the second slide. So the tangent theta is equal to y over x, and the cotangent theta is equal to x over y. Now, the first quotient identity is the tangent theta, which is equal to sine over cosine. Why is it equal to the sine over cosine? Now, let's see this one. Originally, tangent is equal to y over x. So, the numerator is y. So, therefore, in our trigonometric coordinate, y is equal to the sine. So, our quotient identity of tangent, the numerator is sine. Then, how about the denominator? Okay? The denominator originally is equal to the x. So, therefore, the denominator of a tangent is equal to cosine because the trigonometric coordinate x is equal to what? Cosine. So, therefore, tangent theta is equal to sine over cosine. Then, for our cotangent, just get the inverse. So, cotangent is equal to what? Cosine over sine. Let's move on. Now, let's discuss the Pythagorean identities. So, we will start from the unit circle equation, which is x squared plus y squared is equal to r squared. So, what will be our Pythagorean theorem? Pythagorean theorem is equal to a squared plus b squared is equal to r squared. It is originally a squared plus b squared is equal to c squared. It is the same because c is equal to the radius or the hypotenuse itself. Now, to find the first Pythagorean identity, we are going to equate the Pythagorean theorem into 1. So how are we going to do this? So we are going to divide both sides by r squared. So we have now a squared over r squared plus p squared over r squared is equal to r squared over r squared. So therefore it is equal to 1. Alright. So a squared over r squared is the same written as a over r raised to the second power plus b squared over r squared can be written as b over r raised to the second power. Then it is equal to 1. Now, question, why is it? It is equal to cosine squared theta plus sine squared theta. So let's have this one. So originally, we have the 6 trigonometric function and a over r is the same as x over r. So therefore, it is equal to cosine. Then copy the exponent which is squared, then add the theta plus b over r is the same as y over r. So therefore, it is equal to the sine. Then copy the exponent and add the theta, then it is equal to 1. So that's it. That's the value of our first Pythagorean identity. You can arrange this as sine squared theta plus cosine squared theta is equal to 1. Alright, let's find out what is the Pythagorean identity number 2. So to find the identity number 2, we are going to use the identity number 1, which is sine squared theta plus cosine squared theta is equal to 1. So how are we going to do this? So we are going to divide both sides by sine squared theta. Alright, let's proceed. So dividing both sides, we have now sine squared theta over sine squared theta plus cosine squared theta over sine squared theta is equal to 1 over sine squared theta. Alright, let's have the quotient identity. We are going to apply quotient identity. So we all know that cosine over sine is equal to cotangent. So that's why we have now 1 plus cotangent squared theta. Why it is started from 1? Because sine squared theta over sine squared theta is equal to 1. So we already done, right? Then copy first the 1 over sine squared theta. Okay? Then we will move on with the use of the reciprocal identity. Now, after copying the 1 over sine squared theta, we all know that 1 over sine is equal to cosecant. So, we have now the value of 1 plus cotangent squared theta is equal to cosecant squared theta. So, we can arrange the second identity, which is, we have now cotangent squared theta plus 1 is equal to cosecant squared theta. Alright? Let's have the third identity. So again, we are going to use the identity number 1, which is sine squared theta plus cosine squared theta is equal to 1. But this time, we are going to divide both sides by cosine squared theta. So we have now the equation sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. So we are going to use the quotient identity first. We all know that sine over cosine is equal to tangent. So we have now tangent squared theta plus 1. Why 1? Because cosine squared theta over cosine squared theta is equal to 1. Then it is equal to, copy first, 1 over cosine squared theta. Then we proceed with the use of the reciprocal identity because we all know that 1 over cosine is equal to the secant. So we have now the third identity, tangent squared theta plus 1 is equal to secant squared theta. Okay, question. Why are we going to study the trigonometric identities? It is because you are going to use the three trigonometric identities in simplifying trigonometric functions or expressions. So we have the summary. We have three trigonometric identities such as reciprocal identities. What else? Quotient identity. And the last one is the Pythagorean identities. So that's all for today. Thank you for watching. Thank you for listening. Have a good day, viewers.